top of page 3, you will find a summary of permutation versus combination. Okay, so remember, permutations are arrangements where a different order means a different object. Combinations are arrangements where reordering does not make a new object. Okay, so again, another important thing I need you to remember about both permutations and combinations is that there can be no repetition. Okay, so please remember that. Okay, so you're arranging objects with no repetition. Okay, with permutations, the order matters. With combinations, the order does not matter. Okay, the little box below summarizes this information. Okay, for both permutations and combinations, we are trying to compute the number of ways of selecting R items out of N items. Okay, repetitions are not allowed. With permutations, order matters. With combinations, order does not matter. Okay, and this little line right here is just kind of repeating what we just said. For both of these, we're taking in objects total and we're grouping them in, or we're putting them together in groups of R. Okay, and then the last thing here is the formula for both here. Okay, you do not need to memorize these formulas. I will provide them for you. Okay, but they do involve factorials. Okay, we did talk about how if you have a large number, for example, like if your in value, the number of objects in your set is very large, that could be problematic as far as the factorial. You don't want to do like 50 factorial and have to do that by hand and write everything out. So there are some formulas, just like you saw on the calculator. I showed you how to do factorial on your calculator. There are actually formulas on your calculator that will do the permutation and the combination for you. So I will show you how to do that in the next couple of examples. But the keystrokes for the calculator are listed right here. Okay, like I said, I will demonstrate it on the calculator for the next couple of problems, but the keystrokes here are right here in case you need to refer back to them. Okay, that will make your life easier. Okay, so you don't actually even have to use these formulas if you don't want to. Okay, you could just plug it in to the calculator. Okay, but again, the big part of the problem, because now it's about to start, it's going to go towards more of a word problem. The big thing is being able to tell, are we talking about a permutation or a combination? Or even one step further, is this the multiplication principle? You can't forget about that. Okay. All right. So like I said, I'll show you these keystrokes when we work on the next two problems. Okay. All right. So here we go. From here on out, the rest of this section, okay, you're going to get, it's not really a word problem. The problem is given to you in words and it's more of in a context. And we're going to have to come up with the number of things possible. Okay. So you need to figure out whether each situation is represented by a permutation or a combination. Some of them might be straight up multiplication principle. Okay, so I've got a couple of those mixed in as well. Okay, so you're gonna have to figure out which situation it is and then solve appropriately. Okay, so let's take a look at example 3. Okay, it says in a long distance foot race, how many different finishes among the first 5 places are possible if 50 people are running and exclude ties? Okay. All right, so here we have a race. People are running. Okay. So we are talking about the first 5 places. So you got 50 people running, and we're trying to figure out how many different possibilities are there of who can come in first, second, third, fourth, and fifth out of the 50 people. Okay. So I don't know. I'm going to make up some names. Okay. So let's say Albert's running, and let's say, I don't know, Blanche is running, and Carl, and then Denise, and then Edgar. Okay. Let's say these are the first top 5 finishers. Okay. So the question is, does order matter? okay, if these are my top 5 finishers, okay? Well, yes, it does, okay, because this is one arrangement, okay, where Albert comes in first, then Blanche is second, Carl is third, Denise is fourth, and Edgar is fifth, okay? That's one possibility, okay? But what if Blanche came in first, and then Carl was second, Denise was third, Edgar was fourth, and then Albert was fifth, okay? So that's going to give you a different finish, okay? So the order matters here, okay? And there is no repetition. We can't repeat people, okay? You can't, one particular person cannot finish both second and third, okay? So this is going to be a permutation, okay? Because the order matters, okay? So what we're going to do is we are going to put this together in a little formula, okay? So again, we have to put a big P for our permutation, okay? So how many people, remember the n value is going to be how many people are we choosing from, okay? Well, there's 50 total runners, okay? Remember, these were not all your runners, Albert, Blanche, Carl, Denise, and Edgar, okay? I just made up a group of people for the top 5 finishers, okay? You have 50 total people in your set running, okay? And we're trying to figure out how many different first 5 place finishes are possible, okay? So we're going to put them in groups of 5, okay? So we're arranging these 50 people in the different first, second, third, fourth, and fifth places, okay? So this would be a permutation of 50 people taken 5 at a time, okay? All right, so we can plug into this, okay? We can plug in the formula, okay? This is your N, this is your R, okay? So this would be, remember, you're going to do n factorial. If you look at your formula, you can go back up here, okay, right here, okay? It's going to be n factorial over n minus r factorial, okay? So this is going to be 50 factorial over, in the bottom, you're going to have n minus r factorial, okay? And then calculate it, okay? So this is going to be 50 times 49 times, well, actually, before I do that, let's do this. It'll be easier to see this way. Let's do 50 factorial. Let's take a look at that denominator, okay? So 50 minus 5 is 45, okay? So now it's a lot easier to kind of compose here. So this is going to be 50 times 49 times 48 times 47 times 46 times 45. The reason I'm going out so far is because the denominator is 45. So I want to catch the 45, okay? So then we go 43 and then we go blah, 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 all the way down to 3 times 2 times 1, okay? And then the bottom is going to be 45 times 44 times 43, and so on. So now I can cancel things. Okay, so we're going to have our 45s cancel, the 44s, the 43s, all the way down to the 3s, the 2s, and the 1s. Okay, so all we need to do is punch this into the calculator, 50 times 49 times 48 times 47 times 46. So let's go do that. Okay, so 50 times, these numbers get big. This is going to give us a big number. Okay, so here we go. All right, there we go. Ooh, that is a gigantic number. Okay, let me see if I can write this down. So let's see, we're going to have, oops, we're going to have this number. Okay, let me go grab the other digits. All right, so then we have 200 at the end. All right, so here we go. This is how many different finishes among the first 5 places can be done, okay? So here's your humongous number. Okay, so what is that? 254,251,200 different finishes among the first 5 places. Okay, that is a lot. Okay, like I said, I would show you how to put this in the calculator. Okay, I don't expect you to do this computation every time. Okay, my big thing here, I want you to understand that this problem was a permutation. Okay, because again, if you're choosing from 50 people, but you're looking in groups of 5, okay? out of those 5 people, arranging them, does the order matter? Well, yes, because that changes, the order changes who's in first place, who's in second place, who's in third, who's in fourth, and who's in fifth. Okay, so I hope you understand that this particular example is a permutation. Okay, out of the 50 people running, you're putting them in groups of 5 and the order matters. Okay, let me show you how you could have gotten this humongous number from the calculator without having to do the 50 factorial over the 45 factorial. Okay, so if you pull up your calculator, here we go. You're basically putting in the 50p5. Okay, so what you're going to do is you're going to have to put in 50 first, and then you're going to have to tell the calculator that this is a permutation. So you're going to hit math, okay, and then you're going to go over to the probability menu again, like I showed you, okay, and that's where the factorial lives. Option 4 is factorial. But if you look at options 2 and 3 here, look what it is. Option 2 is permutation, and option 3 is combination. Okay, so that's what you can use instead of having to apply those formulas with the factorials. But you can do that if you want. Okay, but this is probably easier. All right, we want a permutation here, so I'm going to hit option 2, and it's going to bring up the permutation notation, as you can tell. So this is going to be a permutation of 50 objects taken, hit 5 at a time. Okay, so if you hit that, then we're going to get that ginormous number that we got. Okay, so that's how you can do it on the calculator, and of course, very similarly for combination. But we'll practice one of those when we get to a combination. Okay, so that's it for this problem. There were 254,251,200 different finishes among the first 5 places if 50 people were running.